Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And today we will be explaining the very last example, example 15, part B in this video of Pure Mathematics 1 and topic number 6, Trigonometric Ratios. And I want us to just look at that question and discuss it in this video so that we can exactly extend our knowledge of trigonometric ratios, and by extension transformation of trigonometric graphs. So the question is, sketch on separate sets of axes the graphs of y is equals to the cosine of pi over 3 within the range of minus 540 degrees all the way to 540 degrees. And as always, I would want us to just summarize everything within Mayo, so our magic square of transformation, and it's going to guide us in every transformation. And in this one, we simply talk about Taher should visit Husseina, and there is a negative 1 there, 1 over A, there is A, and there is A there. And as much as we would want to explain this one using any other way, we can already see that the theta is affected by a coefficient which is a third. So this is simply multiplication inside. And multiplication inside is horizontal. This is multiplication inside, which is every multiplication is stretch and inside is horizontal. So this is horizontal stretch of scale factor 1 over A. 1 over A. Incidentally, our A in this case happens to be a third. So it's a horizontal stretch of scale factor 1 over third, 1 divided by a third, which is easily 3. So it is a horizontal stretch of scale factor 3. So what does this all mean? That means all x values multiplied by 3. And where are we going? We need now to have a general graph of y is equals to the cosine of theta. And let's just have a general graph here. And this general graph is the one that we are going to transform differently. So we have, let's talk about minus 90, minus 180, minus 270, minus 360, negative 450, and negative 540. So this is minus 90, minus 180, negative 270, negative 360, negative 450, and of course, negative 540. Note the range. On the positive side, we have 90. We have 90 there. We have 180 here. We have 270 there. We have 360 there. We have 450 there. And we have 540 at that particular point. So the graph of y is equals to cosine of theta, we know it's always going to oscillate between 1 positive and negative 1. And of course we know cosine 0, cosine cosine 0 is always 1. Cosine 90 is 0. Cosine 180, cosine 180 degrees is -1. Cosine 270 is always 0. 360, 1. Cosine, the cosine of 450 degrees is always going to be 0. And the cosine of 540 is going to be, of course, -1. So we have a graph. That oscillates between +1 and -1. On the negative side, the same thing happens. The cosine of -360 is 1. The cosine of, let's talk about the cosine of -450 is 0. The cosine of -540 degrees is again a -1. So generally, we have a graph that runs this way. We have a graph that runs this way. So what we have here is a graph of y is equals to the cosine of x. Fine. Now that we have to transform this one, and we have agreed it is horizontal stretch of scale factor 3, everything that to do with x has to be multiplied by 3. And that's why we have a bigger range from -540 to +540, so that we can actually see when we talk of 0 times 3 remains 0. Remember, the y values are not affected whatsoever. When x was -90, -90 times 3 is -270. So this particular point lands there. And this particular point landing there, you can already see that if we have -180 times -3 is going to be -540. So this particular point where the value of y does not change, it lands here. So you can already see that our graph on this side happens to look like that. That's our graph on this left-hand side. It has to be smooth and continuous. This is 90, or it was 90, times 3, 270. So this point comes here. This is 180 times 3 is going to be 540. So this particular point comes there. On the other hand, on the right hand side now, the graph now looks like, it looks like that. So you can already see the red graph is the graph of y is equals to the cosine of theta over 3. And that is just like it. You can already see that it has been stretched so much 3 times. You can see that graph, what we have come up with, the red graph. The graph of y is equals to cosine theta is stretched horizontally with scale factor 3. And the period of the cosine theta over 3 is actually 1080 degrees. Because you can see from this particular point, it starts going up all the way to where it gets back to the same point, and again start going up. It is -540 to +540, and the period now, the period is 1080 degrees. That's the period of that graph. after, or rather, it repeats itself. The graph repeats itself after 1080 degrees. Well, it completes. The curve crosses the theta axis or the x-axis at negative 270 and positive 270, and that one has been seen, and that is just generally what we need to know. It is transformation. It is just stretched along the x-axis. It has been stretched, and that's what we have. Fine, that is the end of example 15 and part B. Please note, without Mayo, you cannot do much. Concentrate so much on Mayo, and periodically or constantly revise and put Mayo in mind. Thank you. And again, go to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. Then subscribe, and of course, share. Thank you.